proofs. And I think if we do our algebra proofs, which we are comfortable with solving algebra problems, if we set them up the way we're going to have to when we get to the geometry ones, it's going to make those so much easier, okay? So we're going to practice today what we're going to be doing on Friday, but we're going to do it with algebra so it'll make it easier. Okay, so first thing is, what is a proof, which is where we're headed? A proof is simply an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. A proof is a step-by-step process that takes you from some given information to a conclusion. Today we're going to do that with just algebra equations. We're going to start with an equation and we're going to solve our equation. But when we do it, we're going to give a reason for every single thing we do. Okay? And we can't skip any steps or combine any steps. A proof is specific, exactly what happens. When we get to geometry ones, we'll be using a lot of definitions and theorems and postulates, and that's where those things are super important that you know them. When I have students who struggle with proofs, it is usually because they have not spent enough time studying their definitions, their theorems, and their postulates. It's not because they don't know how to think about what comes next. It's that they don't know what comes next because they don't know the theorem. So I want to remind you one more time in your book, at the very back, when we start working on geometry proofs and you're struggling, one nice little thing this book has is they have all the theorems and postulates by chapter divided up. So if you'll find this little sea green section, aqua blue, whatever color you want to call it, if you'll find that section in the back of your book, it will list chapter 1, all the postulates and theorems that we learned. Then chapter 2, all the postulates and theorems that you're gonna learn this chapter. And so right now, we don't really have that many considering how many we're gonna have by the time we're in chapters 10 or 12, right? But right now, this will help you. So if you're going, oh, I think we talked about something like that, but I don't remember what it's called, then scan back here and see, can you find the theorem or the postulate, okay? While you're studying and doing your homework. And then by test time, hopefully we will have used it enough, you'll know it. And then it could be a definition. We had 50 words we learned in chapter 1, so you may have to go back and think about those definitions from chapter 1. Pull out your vocab study guides that we used and use those, or use your Quizlet. Okay, but again, for a proof, you're going to give a reason for every single step, and they're going to call that a justification. So we're going to give a justification for every step. Before we can get started with our algebra proofs, we need to review some properties you should have learned back when you first started solving algebra. So the first 4 up here are some of the ones that I know for sure you learned in Algebra 1. They are the addition, subtraction, multiplication, and division properties of equality. I will make you write that all out, no abbreviations. The only thing you can do is instead of having to write the word equality, you can put of and then the equal sign if you would like. Anywhere we have a symbol, I will let you use your symbol. So if you want to change these all to just an equal symbol, that's fine. It'll save you from having to write the word equality. But you cannot abbreviate. It's not the add property of equality. It's addition, subtraction, multiplication, division. You're going to use these properties when you are doing these things to both sides of the equation. I want to warn you, you have to do it to both sides of the equation. Most common mistake is what I'm getting ready to write on the board. I will see students who do this. They will say 2x plus 3x is 5x, and they will say that they used the addition property of equality. That is not the addition property of equality. The addition property of equality says if you add something to both sides of the equation. Did we add something to both sides of the equation? No. Subtraction property says you have to subtract it from both sides of the equation. Multiplication, you're multiplying on both sides of the equation. Division, dividing on both sides of the equation. I hope I've said that, both sides of the equation, enough. It is on both sides that you use one of these four properties. If you're just combining like terms on one side of the equation, then that is going to be called one of two things. Add it down here in your notes because it's not on here anywhere. You can either write combine like terms as your reason, or if you would prefer to shorten that a little bit and not have to write 3 words, you could also write simplify. So I'll accept either one. So if you are just doing it to one side, you're just combining like terms, you're going to put simplify or combine like terms. If you're adding to both sides, it's addition property. Multiplying on both sides, it's multiplication property. Does that make sense? And all of them are of equality. Okay, the next 3 I'm going to come back to in just a second. These are new ones that you probably have not used before. Let's look at the last one down here, substitution property. Substitution property is what you're going to use when you have something like this. 2x plus 3y equals 10, y equals 4. If you're trying to solve here for x, what would you need to do with the fact that y is equal to 4? Plug it in. So when you see yourself taking a number and plugging it in for something else, that's the substitution property of equality. Okay? So if you're substituting it in somewhere else so that you get 2x plus 3 times 4 equals 10, what you did to get from what was here to here is substitution. And it is also property of equality. Because there are some of these that are going to turn into of congruence later when we have the same kind of thing, but we're using a congruence symbol. So we're going to be really picky that we put of equality when it's of equality and of congruence when it's of congruence. Okay, these 3, reflexive, symmetric, and transitive, are huge for geometry proofs, and you'll use them some today. Reflexive property says A equals A. Something equals itself. 5 equals 5. 10 equals 10. In geometry, you're going to see it in problems like this. If I have these 2 triangles and I'm trying to prove that those 2 triangles are congruent, then I may need to say that this side AB in triangle 1 is the same as this side AB in triangle 2, trying to show that this side length is the same. So in my proof, I may need to say something like AB is congruent to AB. I'm saying that side length is congruent to itself. If you are saying something is equal to itself, then that is the reflexive property of equality. If you were saying it was congruent to itself, in a minute we're going to look and it's going to be called the reflexive property of congruence. But anytime this is identical, it's just reflexive. A equals A, 5 equals 5, AB is congruent to AB. Okay, symmetric. Symmetric flips. If you want to, you may add that here to kind of remind yourself. Symmetric's going to flip it over. That's the property you're going to use a lot today. For example, let's say that I have this problem. And I want to solve it for x. What would I do to solve for x? Okay, what am I going to do to solve for x? Divide by 5. So what property am I going to use first? Division property. If you say you're going to divide, then you're using the division property. So I would divide both sides by 5. I would not get x equals 2. I would get 2 equals x. We get in a really good habit in Algebra 1 of flipping that over in our minds, right? And we write on our paper x equals 2. But when you flip it, what you used was the symmetric property. And you're going to have to list that on your proof. So when you flip it, if A was equal to B and you flip it over and say B equals A, if 2 was equal to X and you flipped it over to say X equals 2, that's symmetric property. It just flips the equation over. Your proofs will not be finished until your variables are on the left. So if your variable is on the right, you have to flip it over for your final step in your proof. Okay, perfect. Okay, and then the last one is called the transitive property. The transitive property is going to take 2 equations. and it's going to combine them to get a third equation. It looks like one of our laws that we learned last class period. The difference is this is dealing with equations and not if-then statements. It's going to say if A equals B and B equals C. Notice that both of them are equal to B, right? You're going to get rid of the part that they have in common. This side of the equation is going to go away. This side of the equation is going to go away. And you're going to write what? A equals C. Just like the law of syllogism. P implied Q, Q implied R. So we got rid of the Q's and we got P implies R. The only reason it's not called the law of syllogism is because it's equations and not if-then statements. But it is the same idea. A will equal C. Okay, I'm going to give you a little trick that will help you as well. If you are confused, which one's reflexive, which one's symmetric, which one's transitive, these are alphabetical. R, then S, then T in the alphabet, right? R, S, T if you say your ABCs. Notice how many equations there are. Reflexive is one equation. Something equals itself. Symmetric has two equations. It takes the equation and it flips it over to get a second equation. And transitive uses three. It has two equations that you combine to get a third one. So a way you can remember it is RST 1, 2, 3. So if there's one equation, that's reflexive. If there's two equations, that's symmetric. If there's three equations, that's transitive. Does that make sense? Okay. I want you to flip to the very back of your notes and find, because I'm going to let us practice that a little bit. Sorry, it's going to take me just a minute to get there. Okay, find this chart, properties of congruence. So sorry, not the very, very back, but the page before. Does everybody see this properties of congruence chart? Okay, it's the same three properties we just talked about, but notice what's changed. It's reflexive property of congruence, symmetric of congruence. Again, if you don't want to write out that word congruence, I will let you replace it with the congruence symbol. So if you want to change those in your notes to make that a little easier, but you do have to write out the entire word, reflexive property of, and then congruent symbol. So here is where, again, it is RST 1, 2, 3. Reflexive simply says something is congruent to itself, like EF's congruent to EF, like my example on the board. Symmetric takes a congruent statement and flips it. If 1's congruent to 2, then we can say 2's congruent to 1. And then transitive takes two congruent statements and combines them to get a third. If PQ is congruent to RS and RS is congruent to TU, what's the part that is identical on both congruent statements? RS. So we get rid of the RS, get rid of the RS, and we say PQ is congruent to TU. Do you guys see the difference? Okay, I want to warn you about a common mistake, and it goes back to substitution. Notice that when I look at these two equations, this left side is not the same as either side of this equation. This right side is not the same as either side of this equation. So this is not transitive. We are just replacing one little piece, right? That's substitution. Transitive would look like this. If 2x equals y and y equals 3x plus 7, what could I write next using these two equations? Look at the two equations. What is the side that is identical in both of them? What side in this equation is identical to one side in this equation? Y. Do you guys see that this whole right side is the same as the whole left side? So if you're getting rid of one whole side and one whole side because they're identical, that's transitive. That is not substitution. What would my new equation say? Okay, and what you did was transitive property of equality. Of equality because it was an equal sign. So if you're replacing just one little piece, that's substitution. If the whole side matches the whole side, that's transitive. Does that make sense? Okay. Bailey, do you have a question? Okay. All right, so what I want us to do is practice before we even get into any kind of proofs. Let's practice this. So the first one's here on the very back. So go to the back of your notes. And we're going to do this together, and then I'm going to let you with your partner try the next ones, okay? So it says identify the property that justifies each statement. Which property would say angle QRS is congruent to angle QRS? Reflexive, it's an X, by the way, reflex, like you're flexing your arm. Reflexive property of what? Okay, the symbol that's in the statement needs to match the symbol that's in your reason. So reflexive property of congruence. Okay, what about B? Measure of angle 1 equals measure of angle 2, so measure of angle 2 equals measure of angle 1. What is it? Symmetric. Notice it's just what? They just flipped it, right? If you're just flipping it, that's symmetric. Symmetric has two M's, by the way. Symmetric property of what? Equality this time because it's an equal sign in the statement. Symmetric property of equality, and we will be picky about that, so be careful. Okay, C. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Transitive, notice there's one equation here, or congruent statement, another congruent statement, and then we have a third congruent statement, and they had one whole side on each one that was the same, CD, CD, those went away, and we combined it to get AB was congruent to EF. That is transitive property of congruence, because your symbol is a congruent symbol. Okay, this symbol has to match the symbol in your answer. Last one, 32 equals 32. What is that? Reflexive property of equality. Okay, one last thing I want to point out before you try the next four is my little trick I told you. RST, 1, 2, 3. Look how it worked. One equation, R. So RST, 1, 2, 3. When it was symmetric, how many equations were there? 2. When there were 3 equations, it was transitive. 1 equation, reflexive. Does that help? Maybe? Okay. Try the next slide, you and your partner, and then we'll check it. Okay, let's start checking. 4A, what did you get? Let's go with Jack Smith. Very good. Symmetric property of equality. Remember, I will not let you abbreviate. You do have to write it all out. The only thing you can do is the equal sign. So even though the book and the notes may abbreviate, you need to write it all out, okay? Symmetric property of equality. Alex, 4B. Very good. Reflexive property of equality. 4C, let's go with Faith. Very good. Transitive property of equality. And the last one, Chris. Careful of congruence. Make sure that symbol matches the symbol in your statement. So you're correct. It is symmetric property of congruence. Any questions on these new properties? Okay, let's go back in the notes then. And there was one property we didn't mention because it wasn't on that first page of the chart. Okay, and that's here. So find where it says the distributive property. It should have been right at the bottom of that front page. Do you guys see that? I don't know why they made this a separate one instead of just putting it on the front page, but I need everyone right now to add to your notes, it is the distributive property of equality. Okay, it also should be of equality just like everything else today. Distributive property of equality. If you're solving an algebraic problem and you have a number beside a set of parentheses and you need to distribute that number, then your reason is the distributive property of equality. Okay? So when you think, what am I going to do? That typically is your reason. So we're going to try to do one proof at least, maybe a couple, before we run out of time. This is where I'm going to set it up, different than the textbook, because this is what you're going to have to do for every geometry proof for the rest of the school year. Okay? So what we're going to do when we're working these problems is we're going to do 2-column proofs. In all school year, we're going to do 2-column proofs when we're doing proofs. What that means is you're going to create what looks like a T-chart, making 2 columns. You have to label the left side of your chart the statements every time. The right side of your chart is going to be where we write our justifications, and we're going to call those the reasons. So the left side's always labeled statements, the right side is always labeled reasons. Every time. Okay? 95% of the time, the very first thing you're going to write down will be given to you. There are going to be a few situations where it's not given to you, but most of the time it's going to be given. And on our algebra proofs, 100% of the time it's going to be given. Okay, so 100% of the time today, when you're doing algebraic proofs, you will start with what is given to you. So your very first reason is going to be given. It was given to you. When you're writing your proof, you have to number every statement and number every reason. So you're going to put number 1, here's your first statement. Number 1, here's your first reason. Your first statement is going to be whatever they give you. So in this case, since it's an algebra problem, it's going to be the algebra equation that they give you. So number 1, we're going to write down this equation. 4m minus 8 equals negative 12. When you get to the homework, if it says solve the equation, write a justification for each step, that means write a 2-column proof today. So if you see write a justification for each step, 2-column proof. If it just says name the postulate, theorem, property, that's just naming the property, like what we did just a few minutes ago. But if it says write a justification for each step and you're trying to solve an equation, you're writing a proof. Okay? Here's the part that may be weird. You are not supposed to show your work in a proof. So I know that most of the time I'm like, show your work. You have to show your work. No work, no credit. You're going to have to do that over to the side, not in your proof. Okay, so here's what I mean. If you can't do it mentally, then over on your paper, write down 4m minus 8 equals 12. And then you're going to say, what would I need to do to solve for m? What do you want to do? Add 8. So first thing I would do is think about that. If you're adding 8 to both sides, what property are we getting ready to use? Addition property. So I would put my reason in first. Addition property of equality. And write that out. That's going to be our reason. What you're not going to do in your proof is this step right here. You are not going to put plus 8 plus 8. If you need to write that on your paper, then do it over to the side. What you're going to write as your next statement is the result of adding 8 to both sides. So what do you get after you add 8? 4m equals 20. Okay, 12, oh, sorry, that was a negative 12. My bad. This was a negative 12. So what is negative 12 plus 8? Negative 4. Okay, be real careful with your problem. So what you're going to write as statement number 2 is just the result after you use the addition property. 4m equals negative 4. And you're doing every step separately. Okay, what is the next thing we would do to solve for m? Divide by 4. If I were you, before you forget, I would write your reason. What are we going to do if we're dividing both sides by 4? Division property of equality. Oh, I don't know why it keeps erasing. Division property of equality. Okay, so then now you're going to write what is the result after we divide both sides by 4. Okay, m equals negative 1. Again, if you need to show divide by 4, do it over to the side, not in your proof. M equals negative 1. You are done when you have your variable solved for, as long as it's on the left. If it's not on the left, what are you going to do to flip it over? Okay, symmetric property of equality. So if it had been the other way around, you would have to flip it at the end. Do not flip your equation to start with unless you start with symmetric property. You have to write it identical to what they gave you. Yes, sir. What do you mean by show your work? You mean like this over here? You do not have to write that. If you can mentally say add 8, this is what I get, divide by 4, this is what I get, you do not have to show me your work over to the side. You do have to list every single statement and every single reason, though. The entire proof is your answer. Not too bad, right? Okay, let's try one more. Let's see if we can get through this next one. Okay, this one's pretty easy. So what's the first thing we're going to write down since it says write a justification for each step? Make the chart, 2-column proof. So you're going to make 2 columns. Left side's going to be titled what? Statements. Right side's going to be titled reasons. What's the very first statement that we're going to write down here? 1/2 t equals negative 7. Remember that for today we're starting with whatever equation they gave us. What is our reason for that? It's given. Given is 95% of the time what we'll be writing. Today it's 100% of the time. Okay? It is what the equation was they gave us. Okay, next. What do we want to do to try to solve for t here? Okay, divide by what? Okay, so I could multiply by 2 or I could divide by 1/2. Either one would be acceptable. If I divide by 1/2 or multiply by 2, that is the same thing. But you're going to have a different reason depending on which way you thought about it. So somebody may have multiplication property of equality. Somebody else may have division property of equality. But you should both have the same statement right here for solving for t. What happens if I multiply by 2 or divide by 1/2 when I solve this equation? What do I get? Negative 14. If I multiply by 2, the 2 and the 1/2 cancel, and t is equal to negative 14. If you think about it as dividing by 1/2, to divide with fractions, you actually multiply by the reciprocal. So it turns out to be multiplying by 2 over 1 anyway. So our answer here would be t equals what? Negative 14. And my reason could either be multiplication property of equality or division property of equality. And do we have t by itself? Yep. And is it on the left? So we're done. Does that make sense? Okay. We did not get to enough examples where they get harder or there's some basic geometry thrown in. So this homework